All right, guys. Today is an unscheduled trek into DIY tech. I have two Ender 3 printers that I use on the regular, and one of them decided to violently eject the micro SD card. So I found that the spring on the inside, or the mechanism that retains the card when you push it in against the spring, broke, and the SD card just shot across the room. So what we're going to do today, I ordered some SD card holders, and we're going to take the board out and replace the SD card holder. All right, so if you guys have an Ender 3, you know how this goes. It's got that little card holder there. So I have two of these. So I have one that I use for tall prints, and so I've already started taking that apart. I'm not gonna make you guys sit through extracting the board. I'll show you just briefly how it sits in there. But yeah, we're gonna take the board out. We're gonna desolder the micro SD card holder, and we're gonna put a new one in there. So here we go. Just show you how all of this is in there, and it's just a ton of connectors. So we're gonna undo all those connectors. And what I like to do is I take a picture of this before I pull everything out of there, so that I have a reference to put everything back. But next thing you're gonna see is this board is going to be on the bench, and we're going to go through the process of desoldering and replacing the SD card. Oh, I think I just dropped it. But you can see there, here's the micro SD card holder, and it's already got a red C on there that came from the manufacturer like that. I don't know if they were thinking, oh, that's questionable, we'll put a red C on there. All right, anyway, let's go ahead and get that done. And yeah, I just have two printers, because what I do is we'll probably do a video on it, how to maximize your print time. And I put obviously we don't have a dual print head on here. So what I do is I put the large prints, or the prints that take a long time, on here, and then I fill up the bed on here with prints that that will all be quickly printed, or take a short time to print, and do it that way. And that just cuts the time a little bit when you're printing a lot of parts, and you can split them up by smaller prints and larger prints. You can change out the smaller prints on the one print bed and start printing again before the larger print is done. And so there are things obviously that you have to do, small changes that you have to make in order to have the smaller parts print correctly if you're hopping around on the print bed versus printing one large part. But we'll address that in another video when we get to the 3D printing stuff. Okay, so big surprise, change of plans. All the connectors have hot glue on them. I'm sure it's the ESD safe type of hot glue. But cool thing. So in manufacturing, I've been at places where they do this, and this is just to keep the connectors from popping out if you have a lot of vibration going on. And so they've done that here. So what I'm going to do, I don't want to disturb that. So what I'm going to do is I'm going to try to do the replace this. Just put the 3D printer up here and see if I can replace this in place without removing the connectors. We'll see how that goes. But here we go. They came in. Let's take a look. Let's take a look inside and see what we got. So, yep. So just got these in. There's a lot of bubble wrap. Green bubble wrap. Green bubble wrap. All right, so we're gonna get the scissors on this thing and see. Yeah, these are the old craft scissors from back in the makerspace days. These were great because they didn't have any points on them. So when you have the younger kids in the class, these were really cool. But anyway, we're not here for that. Let's see. Oh, here we go. So, wow. And guess what? I got some extras because I have another project that I'm working on. And they were relatively inexpensive. It was like $2 for a set of 5 or something like that. We'll see how good they are. But you can see there, have enough to do a few projects. And, you know, on top of this one. Okay, so for this, we're obviously going to need a good soldering iron. This one reaches 350 degrees at least. It actually goes up to 500. I have never used it at that because it would destroy the PC board that you're working on. This one will hit 350, which is more than enough to take care of this job today. So we've got that. And the tip, let me see if we can focus on the tip there. Yeah, don't try this at home. It's hard to gauge where I'm sitting there. But we've got a not the super fine tip, but the fine tip on there, because we'll have to solder the pins once we get the actual connector on there. And then we've got some flux. Like to use some no clean, because what can happen is sometimes if you don't clean the flux off properly with some alcohol in the brush, you can get oxidation in your solder joints. I'll put a link in the description for you guys if you want to find some good ones. We have the solder wick, and so we're going to use that to clean up the PCB after we remove that the SD card holder. And lastly, we have some solder here. So this is I know we've got, this one is leaded, right? So you have the old so this one's 60/40. So we've got the 60 silver and 40% lead. And so you have solder out there that is obviously lower lead levels. If you're gonna do a small job like this, I mean, you're not gonna worry about it too much. What tends to happen with lower levels of lead in your solder, sometimes if you don't do it correctly, or you have a lot of vibrations in your PC board, you can get it's hard to create a good solder joint. Sometimes you'll get cracks and cold solder joints, things like that could cause your connection to fail. So I have small jobs like this, I just use the leaded solder. This is a spool holder that I made back in it's been many years, but during my time as an electronic technician and various places that I've worked, I had the opportunity to spend some time in the machine shop with some actual machinists. not the and I learned a few things, and this is one of the things that I made. And this is, it's, I look at it now, it's horrific. It's horrific. You know, there's marks all over it, you know, the finish. But this is something, when I was learning to just marry a bunch of disciplines. And so, and a lot of the work that I do today, when I do prototyping and things of that nature, I will, yeah, I'll do a little bit of electronic work. I'll do a little bit of mechanical work. I'll do, you know, everything from CAD to, you know, the final drawings on things, final assembly drawings. And so just being able to do a little bit of all of that makes it so that, you know, in creating prototypes and things like that, I can go from the design side to, you know, the machinist side, and back and forth. And as they're, you know, as things are being designed, you don't want to design it in such a way that the machinist can't really produce it on a lathe or on a CNC machine. Same thing with electronics. Electronics are cool. You can add so many things to it, but if you cannot mass produce the circuit in a way that it can be, you know, assembled into the final assembly in a reasonable manner, right? So if it takes you 20 hours to put a PC board um, into the enclosure, that's not a viable product, unless you're just making one of, and they're, you know, paying you several billions of dollars to create this one piece product. But anyway, that's the thing. Let's get to the let's get to the replacing of the. Let's get back to the project that we started today. All right, here we go. We got the soldering iron warmed up. Always use, you know, if you have a fume extraction fan, use that. I'm going to make this sacrifice here so that you guys can hear still. And we won't be running one today, but we have one out of the bag here. You can see it doesn't have that curious red mark that the damaged one has. So you can see there. We're going to go ahead and test this before we try to put it in, to make sure that it does indeed work. And there you go. It is a fully functional. So when you do stuff like this, be careful with the pins here. These are the pins that we're going to solder down to the board. And as you can see, they are very tiny. If you can look against my thumbnail there, you can see that they're very, very tiny. So you don't want to bend those. And the way that this component is affixed to the board, it has 4 tabs. See? 4. And so those 4 tabs, we will seek to liberate those as we remove the old one. So now we're not going to be too worried about bending things and pins on the old one. We're going to discard that. That's no good once we take it off. So normally solder blobs are not good, but we're going to use solder blobs in this case to transfer the heat really well, so that we can go ahead and pull up this component. And I'm just going to grab it. Get yourself a good pair of tweezers, and we're just going to grab the corner and pull up on the corner. You can see it's coming up there, and we're going to do that until we have a good bit of space between the board and this component, and we can sweep across there. And we're going to, this is an awkward angle to come from, but I'm going to give it a shot anyway so that you guys can see what I'm doing. Being careful not to get solder on any of the other components, as you don't want any shorts. So you'll see that that connector will start coming up like this, and it may even be loose at the front at this point. So I'm going to try to move that and see what I get. Just be careful that the PC board is going to be hot at this point. So that corner is loose. We're gonna have to work, and so you have to bring the front two off first because the pins are at the back. And so I'll show you how to remove the pins once we get to that spot. But this is a very precarious situation. Now you're gonna see how it popped up there. Yeah, that last bit of solder just let go. Okay, looks like it's loose there. And so try not to pry with your soldering iron, because that will damage your tip. And once you damage your tip and it starts pitting, it will erode back, and you'll see some erosion on there, and you'll see some pitting. And at that point you will know that your soldering iron tip is not gonna last you too much longer. So we're gonna go ahead and pull that up. And again, just being careful. We don't want to pull any pads that are on the PC board off. We just want to mechanically get that a little loose. What we're going to do is we're going to flood the backside where the pins are. Once we flood the backside where the pins are we're going to continuously have the soldering iron tip in motion, so that we're not sitting on one pin for too long. But we're going to flood these pins with solder. Again, this is an awkward angle to do this from, but I'm going to try to get some solder down in there. What you have to do is get it down to the pins, and again, being careful not to. And there you go. And so that has come off, and I'm going to do a little close inspection of these pads here to make sure we haven't lost any pads or any vital connections. Sometimes pads that are not actually wired in will come loose, and if they're not connected to anything, you can lose those pads and still be okay. What you don't want to do is lose pads that are connected, obviously, to signals. So we're gonna get a fresh cut on that solder wick, and then we're gonna clean up the board here. And after we clean up the board, we'll do an inspection on there to see what we have. Looks like everything survives very well. And again, you want to gauge how much or how hard you pull on your components, because obviously if you pull too hard, you will damage the components. And so here we go. Being careful again not to get solder on components that don't need to be affected while you're doing this repair. Okay, that looks pretty good. Looks like we still have all our pads. Amazing. And again, you don't want to heat this up too much, just enough to get all of that solder off of there. Okay, so awesome. What we're going to do now, at this point, we want to get some alcohol and isopropyl. I've got 91% here, and I just used the cap. I just pour some out in the cap. A little bit too much. we just need a little bit for this job, since we don't really have that much flux on there. And then we'll just do that, and that looks pretty good. This pad here in the corner looks like we lost that, but hey, I should have probably used the solder wick on there to remove a little bit more of that solder before I pulled it up. But in the interest of getting on the camera, I sometimes get excited and do a little bit too much. So, all right, so there we go. We've got that cleaned off nicely. And what you're going to see here is 2 holes for locating pins. So you've got 2 holes there. This particular component is really good in that we have the 2 locating pins here. And that's going to allow us to drop this right in there and find the correct position. So you can move it around. Boom, it's in the correct position. So now that we've verified that the footprint is correct, let's look on the pins. See that they all line up really good. The 4 corners line up really good. So now we can pull this guy back off. Why are we pulling it back off? So what we're going to do is we're going to add a little bit of fresh solder. Just a little bit. Just enough to get everything tacked down. And so there is some rosin in the core. So this is rosin core solder. So we're not going to add flux at this time. We're just going to do 1 corner, the corner closest to us, and then we're going to go ahead and do the pins. Just a touch. Not much is needed. Sometimes you don't even need to bring the solder to just like so. Okay. Now we're going to add some flux. So we add some flux to that right on top of there. A little bit across here. And we replace the component again. So here we go. Put that on there, get it in the pins. And what we'd want to do in this case is we want to, and we've only put solder underneath 1 corner. The reason for that is that we're going to secure that 1 corner first. Once we secure that 1 corner, and again, be careful, this will be hot. We secure this 1 corner really well. Once we have that secured, okay, we need to apply a little more heat. Make sure your tip is flat on there. Okay, I see it bubbling. Okay, that's secure. That 1 corner is secure. Now we're going to do the other 3 corners. Just a touch of solder. You don't need too much. Okay. That one's down. Get the last one here. Okay, I've touched one of the components, so we'll have to check that later to make sure I didn't cause a short. Alright, good. Alright, so that's sitting down pretty good. Alright, that feels pretty good. So now we're going to go across the back of these. So I'm going to get close in here so that you can see what's going on. All right, I hope that helps you see a little better. Normally, I would have my mag light in there like this so that I can see what I'm soldering, but so that you guys can see what's going on, I have that set aside, and that helps a lot. I'll put links to the mag light in there for you guys to check out if you want to pick up one of those. But here we go. Now we're going to do the pins on the back side, and it should just be as easy as going across the pins with the soldering iron. Just use a little slight pressure, and you'll feel when the pins give a little and the solder okay. So there you go. I'm gonna smooth this out a bit. Nice. Okay, so there you go. I'll see if I can get the microscope on there to give you a closer look, but that's basically it. So it's we're mechanically on there. We're gonna inspect this closer to make sure that all the pins actually did get soldered, and then I'll actually take a look at this capacitor here. You see it says C42 there. I kind of touched that with the soldering iron, so I'm going to go in and inspect that and make sure I didn't cause a short there. But that's basically it. So you're in there now. And let's give this a mechanical test here. Wow. I would say that's good to go, but again, we're going to check that out. And good thing to do at this point is we're going to usually you'll inspect this first to make sure that it is in there really good. Then we're going to give it a nice cleaning with the isopropyl alcohol and the brush to get rid of any excess flux that we may have in there. And that's it. And we put this thing back together, and we'll give it a test. All right. So we're getting in there really close. So that's what you should see. So you see all those rounded edges on there on the pins. That's what you want. So we're gonna look at the corners. Nice, nice. It's down. That one's also down. This is the one. Actually, this is the corner that we lost before. And here's the final corner. Trying to get it to focus and move the microscope at the same time. It always goes opposite of what you're thinking. But there you go. So, yeah, looks all right to me. We'll see if we can get close on the corner here. Gonna be okay. There we go. Yeah, looks pretty good. All right, time to screw everything back together and test it out. All right, here we go. Please forgive the mess, as I always have a million projects going on. But we're gonna, so I've got it hanging there. I don't have the fan installed, so we're not gonna run it too long. We're just gonna run it long enough to insert the card. and make sure that on the screen we see card inserted. So I'm going to turn this on here, and we've got power, so we don't have any blue streaks or anything that indicates that there's a short somewhere. All right, we're going to insert the card. So here we go. It's weird trying to do this through the... Okay, so let's check the screen. We're going to look on the screen and see card inserted. Nice. And I'm going to pull it back out. Card removed. Okay, good to go. Good to go. The real test is going to be me putting all this back in there, back together. Not going to make you guys suffer through that, so I'm going to reinstall the board and zip it up, and we'll do a test print. And so we'll see you when I get that in there. Okay, let's see the first layer. Let's see what the first layer looks like. Is that recognizable? Oh, yeah. Yep, that's it. I think we're good. I think we're good, people. I'll fast forward to where it's finished the print so you guys can see. All right, here we go, here we go, here we go. 99%. It's about to finish. Let's see what this thing looks like. Okay, I would say that that is a success. Good deal. All right, so there you have it. If you have an Ender 3, and this will probably work on a lot of different boards with the same type of SD card slot. Yeah, don't toss it out. Just replace the SD card slot, and you're good to go. So hope this helps. And again, this is going to be it's not going to be a beginner level soldering. You're probably going to need a little bit of soldering knowledge to get this done, but this will save your printer motherboard if you need to, if you and hey, just have to wait a few days. The card got here, and we're back in action here. So again, as always, I appreciate you spending time with me, and hey, like, subscribe, share. That way we can keep all these videos going and keep things like this going out. And we'll see you in the next video.